Welcome to Pi Excellence Tutorials. Just a quick reminder, if you have not yet subscribed to the YouTube channel, kindly subscribe and click on the notification bell. You can also share with others so that they can also benefit to this free gift of tutorial videos. So in this video, we are looking at thermophysics, and the question reads, a grandfather clock is controlled by a swinging brass pendulum that is 1.3 meter long at a temperature of 20 degrees Celsius. And the first question says, what is the length of the pendulum rod when the temperature drops to 0.0 degrees Celsius? And B said, if a pendulum's period is given by T. Okay, so I know here we're supposed to have a division time where L is its length. Does the change in length of the load cause the clock to run fast or slow? And what is the new period? Okay, so this one, we need to find the new length, we need to find the new length, and it's not that different from the previous question that we solved in the previous tutorial video. So if you have not watched the previous question, the first question that we solved under thermophysics, kindly go back and look for that question. So here what we have, we also have, we also have this formula, change in temperature. Okay, so now we've been told that the material here is a brass, so you have to check for the coefficient of linear expansion for brass. Here in the question we have not been given, but it's there on the list. So it's given by 19 by 10 to the power -6 per degree Celsius. That's the coefficient of brass. So now, from here, what we have, we've been given the initial temperature and the final temperature. Okay, so initial temperature is actually 20 degrees Celsius, and the final temperature is 0 degrees Celsius, and the initial length is 1.3 meters long. And what else we're done on that one? So now we know that the change in length is basically going to be L2 minus initial, and we have that. And also the change in temperature is T final minus T initial. Okay, so now this L2 minus L initial, we are looking for the L. We're looking for L. So we're going to have L2 minus 1.3 meters. We are just substituting the values, and the coefficient of linear expansion is given by that. Okay, and then we have 1.3 as well. And then change in temperature, the final temperature is 0 degrees Celsius minus 20 degrees Celsius. So L2 is basically going to be minus 1.3. This is meters, of course. Don't forget that that is meters and that is meters. And then we're going to have okay, 19 by 10 the power -6 degrees Celsius. Okay, 1.3 meters, and this is going to give us actually -20 degrees. Okay, so L2 minus 1.3 meters is going to be equal to, when we punch this, we are going to have okay, so we are going to have negative 4.94 by 10 to the power negative 4. Okay, and that is meters. So we do simple evaluation where L2 is going to be 1.3 meters minus 4.94 by 10 to the power negative 4 meters. And that is going to give us 1.299506 meters, and that is going to be the final length. So now the second part of this question talks about what happens when the length of the pendulum of the rod changes. What happens to the clock? So here what we see is that that was A. Okay. So what we see that the formula for period is given by that 2 pi L over G. So from this, we see that gravitational acceleration is constant in this case, and 2 pi is also constant. So we have a variation of period being direct proportional to the root of length. Okay, so this means that once the length is increased, period also is increased. Once the length is reduced, also period is reduced. So what we expect is that when the length is increased, the time also increases, the period increases, meaning it will take more time for when the length is long, it will take more time to complete one oscillation. To complete an oscillation, it takes more time. So if it takes more time, it means the clock runs slow. Yeah, and when the length is short, you have small length, you have short length, you are going to have you are going to complete that pendulum is going to complete more oscillations in a short period of time. So that it means that the clock will run fast. Okay, so that's the explanation I can give on that one. You can even try that. A simple pendulum, you can make a simple pendulum. That's very easy, you know. Yeah, and try. You have a stopwatch and see what happens when you have long length and short length. You are going to observe this. So now we are told it also to calculate the new period. So using the same formula, we are going to have period being equal to 2 pi root of length, which is 99506, and gravitational acceleration is given by that. So our period is going to be 2.29 seconds. That is going to be the period. Okay, so that is how you get to solve that question. So if you found this video to be helpful, kindly share with others, give me a comment, and we'll appreciate. Okay, see you in the next video.